Hi, and welcome to Statistics Day 1. Okay, we have a lot of notes here. There's a lot of reading involved with these. I am not going to read everything to you. I expect that you're going to go through and read these notes on your own and then ask any questions about anything that you've seen here. I'm just going to go over the highlights and then spend the time actually doing the problems with you. Okay. Just generally speaking, statistics is the science that deals with the collection, organization, summarization, and interpretation of related information called data. Univariate statistics is what we are going to be working with. And univariate statistics consists of one number for each data value. We have a collection of data, which is how there's methods as to how we collect them. And the first method is a survey, which is it's used to collect quantitative information from a specific population. Survey may focus on opinions or factual information depending on the purpose of the study. Surveys may involve answering a questionnaire or being interviewed by a researcher. Okay, I have the advantages of a survey listed and the disadvantages and some other information. An experimental study. The researcher takes measurements or surveys and sample population or surveys the sample population. The researcher then manipulates the sample population in some manner. After manipulation, the researcher remeasures or resurveys using the same procedure to determine if the manipulation possibly changed the measurement. Okay, we have a controlled experiment. That's like that Regents exam question that we talked about a while back. The researcher will separate the sample population into groups, with one group established as the control group. All groups will be manipulated in some manner except for the control group, which remains the same. This was like the fish eggs, and we put the box over the one and not over the other. Okay, an observational study. In an observational study, a sample population being studied is measured or surveyed as it is. The researcher does not influence the population in any way or attempt to intervene in the study. There is no experimental manipulation. Instead, data is simply gathered and correlations are investigated. And then we finally have a census. Every 10 years, the government conducts a census to determine the U.S. population. Each year, almanacs are published that summarize the updated data of general interest. This is a study of the entire population. This is a type of survey. A census deals with the entire population. It doesn't necessarily mean the entire U.S. population. That is just an example. If we're talking about a group of ninth graders and we were to conduct possibly a survey on the ninth graders and use all of the ninth graders, we are still using a census. Okay. Sometimes it's not feasible to use the entire population. In these cases, we use a sample. For example, in order for a company to determine the quality of the product, the quality control department of a business may study a sample of the product being produced. Samples must reflect the properties of the whole group. The sample must be representative of the group being studied. The sample must be large enough to be effective, and the selection should be random or determined in such a way as to eliminate bias. So, for example here, for number 1, a new medicine intended for use by adults is being tested on 5 men whose ages are 22, 24, 23, 27, and 30. Does this sample provide a valid test? Why or why not? Well, in this case, the answer is no. It is not a valid test. It's not a valid test because the ages are in a small range. And the medication is for adults. The other problem with this is only testing men. Okay? And it's too small a group. This sample does not represent the entire population that we have here of adults. These are all young men, and there's only 5 of them that are being tested. So this is not a valid sample to go by. Example number 2, the management of a health club has received complaints about the temperature of the water in the swimming pool. They want to sample 50 out of the 200 members of the club to determine if the temperature of the pool should be changed. How should this sample be chosen? Okay, I want you to come up with some ways in which you think the sample should be chosen. You write them down. When we go over things in class on Monday, I will be checking this, and we will be going over this answer together. I want you to come up with ideas on your own. So I'm not going to fill this out for you. Alright, we have the organization of data. There are many different ways to organize data, depending on whether you have a large set of data or a small set of data. You may find it easier to use different methods. For smaller data, a stem and leaf diagram can be very helpful. If you have larger sets of data, a frequency distribution table would be useful. Okay, so for example 3, the prices of a gallon of malt for 15 stores are listed below. A, organize the data in a stem-leaf diagram. B, display the data in a frequency distribution table. C, if 15 stores are chosen at random from more than 100 stores that sell milk in Monroe County, does the data set represent a population or a sample? Okay. In a stem and leaf diagram, I don't know if you remember doing these or seeing these, you have a little chart. This side is the stem, this side is the leaf. And in the leaf, you have your last value of your data. Okay? I'm going to be looking at the pennies, not tens, not the tens. I'm looking at the units, the ones. Okay? So I'm going to look at those, and that's going to be on my leaf side. My stem is everything prior to that. When you do a stem and leaf diagram, you have to have a key. And the key, so that we understand what we're writing, is if I were to have $2.98, my key would be 2.9, and then I'm going to draw a slash, because that's representing a line here, 8. So this represents $2.98. So it looks like 2.9 slash 8. And this equals $2.98. Okay? So when we do our stem and leaf diagram, they must also be in numerical order, either highest to lowest or lowest to highest, depending on how you look at it. Right, my highest value, if I look at my data, is here. My highest value is $3.58. My lowest value is $2.98. Okay, and I'm going to start at my highest value and work my way back. I have nothing else in the $3.50 range. So on this side, I'm going to put 3.5 and then the 8. Now I'm going to look for something in the $3.40 range. If I look into my data, I have a $3.40 and I have a $3.45. So I have a 0 for $3.40 and then a 5 for $3.45. I need to put these in order. Now I need to look for a $3.30 range. Okay, if I go in months, I have a 335, a 330. Anything else? 330. Is that it? 339 up here. So we have a 0 for 330, 335, and a 339. Next, we need to look in the $3.20 range. There is quite a few of those, and in order we would have a 324, two 325, so we have 5 and 5, and then we have a 328 and three 329s. So I have to have 3 9s to represent all three of those. Then we need to look in the $3 in the teen range, and the only thing I have is $3.15. So then I look to look in the 3 O's, and I actually have nothing there, so I leave it blank. I don't put a 0 because that one if I had a $3 a gallon. And then my very bottom one is the 298. This is just a sum-leaf diagram. It represents the data. One way of looking at it. And then in part B, it asks us to display the data in a frequency distribution table. Well, in the table, first thing we're going to have listed is our price. And we're going to do it just like we did over here, except in a range. And this one would be 350 to 359. And then I would have my tally marks, so I can mark my data. And then the very last column is frequency. Frequency simply means how many. Alright. My next range would be 340 to 349. And then 330 to 339. My next one down will be 320 to 329. And then 310 to 319. And $3 to 309. And the very last one we'll have is the 290 to 299. When I list out my prices, my ranges, my intervals here underneath the price column, my intervals have to be even. So whatever I make the length or the width of the first interval, all of them have to match. We could go back and tally like you did back in algebra. There was 1 in there, there's 2 here, there's 3 here, and then here we had 7. In this set we had 1, here we had nothing, so we leave it blank, and 1. Frequency is just the number of tally marks you have. 1, 2, 3, 7, 1, 0, 1. And if you look at our sum leaf diagram and our frequency column, frequency table, they actually line up. I have one piece of data over here in my leaf. Here I have 2, here I have 3, here I have 7, 1, 0, and 1. And then the last one says, if the 15 stores are chosen at random from more than 100 stores that sell milk in Monroe County, does this data represent a population or sample? Well, in order for it to represent a population, it has to be all of the 100 stores, and since it's only 15 of them, this is a sample. Okay, this should look somewhat familiar to you. This is summation notation. We worked on this back in January. it actually does come into play in the statistics, so I want to review what it means. This is the Greek capital letter sigma, and it's the meaning take the sum of what follows. This number here is what we call the upper limit. And then down here, the variable is what we call the index. The number down here is what we call the lower limit. Okay, what this is saying is the sum of I when I is equal from 1 to 5. You can use any letter in your sigma notation, but do not confuse the I with the square root of negative 1 or the complex numbers, or just circle with I on it, because that's not what it is. The I just stands for index. It's just a variable in this problem. So let's look at our examples. For example 1, we have I going from 1 to 5. So that's simply 1 plus 2 plus 3 plus 4 plus 5. We start at 1, we go to 5, we substitute into I. When I add that all up, it equals 16. For number 2, I'm starting at 2 and I'm going to 6. So it's 2 plus 3 plus, the thing that changes is the J, 3 plus 3 plus 4 plus 3 plus 5 plus 3 plus 6 plus 3. And then I just add everything up. This is 5 plus 6 plus 7 plus 8 plus 9. I'm going to add all those numbers up, I get 35. I'm going to do the same thing for number 3. So this time I have I squared and I'm starting at 0. So it's 0 squared plus, let's get on that, 1 squared plus 2 squared plus 3 squared plus 4 squared. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. When I add all those up, I get 30. Number 4 is a little bit different because we have a number out in front. So what we need to do is just take our answer and multiply it by 3. So it's 3 times, starting at 0, 0 cubed plus 1 cubed plus 2 cubed plus 3 cubed. I stopped at 3 because my upper limit says 3. So this is 3 times 0 plus 1 plus 8 plus 27. So this is 3 times 36, which is 108. Oh, this next one looks like fun. I'm only going from 0 to 2, so I'm not really going that far. I'm going to put in 0, 1, and 2 for n. We have the sine of 0 squared plus 1 pi over 2 plus the sine, my mistake here, don't want that line there, because it's the sine of this whole number, the sine of 1 squared plus 1 pi over 2 plus the sine of 2 squared plus 1 pi over 2. Now if I go back and clean that up, this simplifies to the sine of pi over 2. This is 1 times pi, which is 2. Plus the sine of 1 squared is 1 plus 1 is 2. 2 pi over 2. 2 pi over 2 is pi. Plus 2 squared is 4 plus 1 is 5 pi. The sine of 5 pi over 2. And then we simply just need to evaluate this. We would have the sine of 90, which is 1, plus the sine of 180, which is 0, plus the sine of 5 pi over 2. Well, 4 pi would be the same as 360. It would be the same as, 4 pi over 2 would be 2 pi. So that'd be the same thing as 360. But here I have 5 pi over 2, which would be similar to 90. Okay, if we keep going around, it's equivalent to 90. And 1 plus 1, sorry about that, 1 plus 1 equals 2. And I add them up. Alright, for number 6, if x sub 1 is equal to 12, x plus 2, x sub 2 is 15, x sub 3 is 18, x sub 4 is 14. Find, I think this is supposed to be 24. I need to check on that number. That does not look right. So this would be 12 plus 15 plus 18. Well, we'll go with it because we're going from 1 to 4. Plus 14. I need to add all those up. This is 27 plus 32. So 27 plus 32 is 59. They gave you all the terms, all you had to do is add them up. For number 7, we need to use sigma notation. Now remember, I said this before, there's several different ways to do this. I'm only showing you one that's right. Most of the time we start with I being 1 or K or J or whatever letter you're choosing. So in this case, I'm going to let N be 6 to 9 of just 10. That will give me 6, 7, 8, and 9. This one is also arithmetic, so I could do this with an arithmetic problem. And my common difference is just 1. So we could use our formula. We have A sub n is equal to A sub 1 plus n minus 1 times d. So in this case it would be 6 plus n minus 1 and b is 1 in this case. So it's just 6 plus n minus 1. So it's 5 plus n, and we would start from 1. N equals 1, 2, and we have 4 terms, 4 of 5 plus 10. Those are both correct. Sigma notation. The letter B is neither arithmetic or geometric, but these are all special types of numbers. And the types of number those are perfect squares. So n equals 3 to 1, 2, sorry, 3, 4, 5, 6, 7, 8. From 3 to 8 of n squared. Alright, for letter C, again, this is neither arithmetic or geometric, so we just kind of got to look at what we have. And equals, this is 2 cubed, this is 3 cubed, and we can put that over 1, and I bet you we could have 1 cubed there. So really, this is just 1 over n cubed. And if I start with 1 to the third power is 1, divided by 1 is 1. Then I put in 2. 2 to the third power is 8, 1 over 8, 3. Okay, so this goes from 1 to 3. So it's just a little bit of extra practice of something that we have already done before, and that we will kind of see again in this unit. And if not in this unit, we will see it again on the Regents exam. Okay, sorry that these were a little bit longer tonight, but we are through this. This should be the longest set of notes, hopefully. We'll see you in class later. Have a good night.